scenario, and then we estimate the NPV, taking the probability into account. So we, in other words, we add the components, or at least probability, or the chances of occurrence of the events, so that we have some certainty. Because sometimes maybe the chance of, let's say, worst case scenario occurring a bit limited, and therefore it's not something that you need to worry, but it could be too huge to the extent that it's the most likely, or it's the one with the highest chance of occurrence. So probability have implications on the NPV, and the argument that we're making here is that we need to incorporate risk. Okay, so yeah. So so if we take project X as an example, so we already computed the NPVs, which you recall, or that you did. So suppose now we are given the probabilities. So you see, for example, here you have maybe 25% chances of worst scenario happening, and it's 50% of, most likely happening, and then you have 25% for the best scenario. So in other words, the most likely case is the one with the highest probability. So now once you have the probabilities and you have the NPVs, you can compute the expected NPV by multiplying. So you take the worst NPV, multiply by the probability, you get the value for most likely, best case, and then you aggregate them, and I hope you're going to get the expected NPV there. Should you try in a minute? Just cross check. Maybe you multiply the NPV for the worst case times the corresponding probability, and see if you get the value of 1,409. Is that what you get, students?
Yes.
Okay, so if yes, then you do that for the most likely, but also best case, and then you add the adjusted or the expected NPV, and I think we are getting 20,848. So you do that also for project Y. You have probabilities which I think are similar, and then you multiply with the corresponding NPV. And I think you're also getting the expected NPV, which is 20,448. So in other words, just looking at the NPV for different scenario was difficult to pick between the two projects. Project X and project Y, because you see different values, and they're not like easily comparable. But the moment we adjust for probabilities, now we see that maybe the two projects are similar when it comes to expected NPV, because they give, they arrive at the same value. So then it's just the question of the question of the risk that I mentioned before. It depends on risk orientation or attitude of the investor. Yeah. So now we have another case here, which I wish we do this way. I will undo anyway. Yeah, so we have another case here. Let's say of a typical, typical project. So you have a case here because that was like equal amount of cash flows from year one to year, I don't know, what was that? 16 and so forth. So now here, and equal probabilities. But now you have a case of sensitivity analysis adjustable probabilities. But what you see here, maybe the cash flows are equal. No, they're different. No, they're equal. So you have cash flows for year one, cash flow for year two, cash flow for year three. I mean, they're possibly equal. Maybe the worst case is 3,000, most likely 6,000, and the best case is 8,000. But then the probability for the first year, I mean, somehow different with the probability of second year and probabilities of third year. I hope you can see that. Students?
Yes.
You can see. Yeah, so
See.
yes. So remember with the previous example, I mean, we went to adjust probabilities after computing the NPV, but in this case, we will have to adjust, I mean, for probabilities on the cash flows because the probabilities are not similar, I mean, throughout. So in that case, you have to take the expected value of cash flows. And what you do, you simply multiply the cash flow times the probability, and I hope you have the value there. So you do that for year one, you do that for year two, you do that for year three. Is that clear, please? If something is unclear here, please ask. But I mean, sorry?
May you repeat?
No, I'm saying if I take you back here, remember this project. I don't know if, yeah, here. So you see this project. This project, you're told the cash flows estimates for t equal to 1 to 15. These are the cash flows. Are we clear there?
Yes.
Yeah, so you are given the cash flows for year 1 to year 15, that for project X and for project Y. So we computed the NPV using these cash flows, and these were the NPVs for 15 years. So, and then later we went to adjust for probabilities. So what we did is displayed here. So we adjusted probabilities. So the assumption here was, I mean, the probabilities throughout the years are the same. So it's 25, 50, and 25. I mean, from year 1 to year 15. So that's why we simply, I mean, adjusted the probabilities from the NPV. Yeah, but in our example now, the probabilities are different for different years. Do you see that?
Yes.
Do you see that, please?
Yes.
Yeah, so that being the case, then you need to adjust the probabilities, I mean, from the cash flows, not the NPVs. So for example, if I take just the first case, then you take the 3,000, you multiply by 0.25, and are you getting 750?
Yes.
Are you getting 750?
Yes.
Okay, now if you go to the last cash flow of year 3, which is how much?
3,000.
The last cash flow of year 3.
8,000.
The best case, I mean, the best case for year 3 is 8,000, is it?
Yes.
So if you multiply by the respective probability, or how much are you getting?
4,000.
4,000. So, so I mean, I want you to make sense of these values, the values. So the 750, 3,000, 2,000, these are obtained by multiplying the cash flow times the probability. I hope that is clear. Okay, so what you do then? So for example, for year 1, simply for year 1, so because you have multiplied these cash flow with the probabilities, now you have to obtain what we call expected cash flow. The expected cash flow is simply obtained by adding, please, can you mute as I explain? Yeah, so the expected cash flow are obtained by simply taking or adding the expected cash flow for worst case, most likely, plus the best case. So which means you have to add the 750 plus 3,000 plus 2,000. And how much are you getting? How much are you getting there? For year one, what is the expected value?
2,750.
It is?
2,750.
2,750.
Yes.
5,750.
Yeah, I think it's likely to be 5,750 because taking 750 plus 3,000 plus 2,000, I think that is going to be 5,750. Right?
Yes. I thought you said you add the best and the worst scenario only.
No. I meant all the scenario.
Okay.
Yeah, all the scenario. So you do the same for year two and year three. So what is the total value for year two? Expected value?
5,000.
Sorry?
5,000.
Okay, and for year three?
And 250.
It is?
6,250.
Yeah. So now, once you have the expected cash flows, then you have the present value discount factor. Because we have the discount rate of 10%, so you have the discount factor for year one, discount factor for year two, discount for year three. So what is the present value for year one? What is the present value for year one, please?
5,226.75.
Okay, and for year two? What is the present value for year two, please?
4,051.
Sorry, it is?
14,051.
No, the
4,000.
the present value for year two.
Oh,
4,000.
4,130.
Okay, and what is the present value for year three?
14,051.
I don't think the present value for year three, because
It's
remember the
4,000.
expected value is 6,000, so it cannot be 14.
It's 4,693.75.
Yeah. So now to get the present value of the project as a whole, then you add them. And I suppose that is what you have been mentioning, right?
Yes.
Which is 14,051. See?
Yeah.
Yeah.
Yes.
Okay, so I assume that this is what you got, right?
Yes.
Okay. So I mean the present value of this project is 14,051. So when you have different probabilities for different years, I mean for different scenarios, so this is how you adjust probability, or this is how you do the sensitivity analysis. Yeah. Okay, so just to proceed. Now, I want you to work on this, and should I give you 10 minutes? So
Okay.
we want you to check. You have the discount rate of 10% and the initial investment of 12,000. So I want you to evaluate this project and tell us if we should implement or we should undertake this project. So 10 minutes, then I will intervene. I see Alicia raising a hand.
Sorry, sir.
Yes.
What to do on this cash flow that have no probability?
Sasa hapo si ndo najiongeza.
So you put a 0.
No, sijui lakini kumbuka you came to do BCom because you have done mathematics. So jiongeze please. Remember you have a minimum of C ili tukuadmit kwenye BCom. So try to work on that.
Okay, sir. Thank you.
Karibu.
What? Why? Who are you? Why?
Sorry, are you done? Hello.
Yes, sir.
Okay. Yeah.
Yes,
So
sir.
okay, good. So we should be able to proceed now.
Right.
Okay. So I don't have the answer. So I suppose you do. Okay. So maybe what did you, Elisha? What did you do with the probability issue?
I take the summation of those two probability. The remaining one become the probability of empty space. Okay, sir, can you repeat it? I take 0.2 plus 0.3, which is 0.5. Then the probability always total is 1. So I take 1 plus 0.5. The remaining one is 0.5, where I put it on cash flow that you have 400,000.
Sorry, I was muted. I was muted. Sorry. What is the probability for here, year 2? The first probability for year 2?
0.2.
0.2. Okay. And what is the probability, the last probability in year 3?
0.25.
0.25. Okay. So, I mean, the first thing to do was to complete the probabilities, I mean, as we have done. So this is going to be 0.5, if I understood. And then you compute the values by doing what? How do you compute the value here?
You multiply the cash flow times the probability.
Okay, so what is the value here, for example?
300.
300. Okay, so you do the same for all, I mean, the cash flows. So what are you getting is the expected cash flow here for year 1?
3,800.
Okay, for year 2?
7,225.
For year 3?
6,500.
Okay, so and how do you conclude? Should we undertake the project?
Yes.
Why? Why should we undertake the project?
We should undertake the project because it has a positive NPV
Of how much?
of 2,309.
309.
0.17.
For 0.17.
Yes.
Okay. Yeah. So anyway, so that is how you adjust probabilities, or at least you incorporate probabilities in sensitivity analysis, and establish the NPV. So so that is more about the first approach, sensitivity analysis. Okay, so we proceed. So we are still saying, I mean, the sensitivity analysis are adjusted for probabilities. only gives the expected returns, I mean, in terms of monetary value, but it doesn't give the, I mean, the concrete measure or value of the risk or variability. And therefore, we need to have or to use some approaches that gives you, I mean, the value of risk. Because remember, sensitivity analysis is just looking at how variable are the cash flows, but also NPV, I mean, for different scenario or when the conditions are changed or adjusted. But it doesn't, I mean, it's not saying anything in terms of the level of risk. And that is where now we need to, I mean, consider other approaches, and these are standard deviation and coefficient of variation. So starting with the standard deviation, and I mean, when you talk about these two, so in any case, both, I mean, a measure of risk, as I said. But standard deviation is used when the project involves the same initial outlay. So in other words, when you have different projects and equal amount of cash flow, initial or investment, then the standard deviation is, I mean, works well. But this approach is not, I mean, ideal in the cases where you have different investment level. And that is where the coefficient of variation, I mean, makes more sense. So what we are saying, first of all, if we start with standard deviation, so this is more of an absolute measure of risk. So you will see the coefficient of variation is a relative measure. So in other words, the standard deviation is going to give you the absolute value. You compute and get the absolute value of risk. But then the other one is a relative measure in the sense that I mean, you compare some numbers to establish or to get what we call coefficient of variation. And I mean, it's not something complex, but I mean, standard deviation, even by definition, is the square root of the mean of square deviation. So we try to compute from the I mean, from the cash flows in reference to the mean, or how do they deviate from the expected cash flows. So I mean, sorry, I just go back. Yeah. So, and if you have some probabilities, we will have to weight, or in other words, to adjust for the probabilities as indicated. So you have the cash flows, but then, I mean, depending on the number of scenario, then you adjust for the probabilities, for the respective probabilities. So if we take an example, I mean, going back to our example, you recall Project X? Do you remember Project X, please?
Yes, we do.
Yes, sir.
Yeah. Yes. So if you remember Project X, I mean, the expected value, NPV in particular, I mean, were this much. So you take the cash flow, and these were more of NPV of respective scenario, and then you compute the NPV, sorry, the standardization. So possibly working with this might be a bit misleading, but I mean, it's usually logical to work from the cash flows, not the NPV. So we will have a we will have a look on the NPV case. Sorry, the cash flow case. Yeah. So anyway, I mean, comparing these two projects, which were, I mean, the standard deviation were computed for Project X and Project Y. So the standard deviation of Project X, I mean, it's 10,756, and for Project Y is 43 something. So if you recall, when I started comparing the two projects, I said there is a big gap from, let's say, the NPV and worst scenario, which was negative 40,000, to the most likely, which was 20,848, and then the best case, which was I think 81 something. So the gap was a bit huge, and this is reflected now in the actual value, or the absolute value of risk. So you see, project Y has a higher value of risk, and I mean that's match with what I said. So I mean, depending on the NPV, that would be difficult, because I mean, you saw the expected value of NPV for both projects were 20,848. So deciding on the NPV or sensitivity analysis was a bit difficult. But now, using the standard deviation, I mean, you can easily compare the two projects and conclude that project Y is more riskier than project X. So what we are adding here is that now, with the standard deviation, you are able to estimate the level or how risky is a particular project, and make some informed decision. Yeah. So I mean, if you are risk averse, obviously you go for project X. Yeah. But as I said, it's a bit difficult for project with unequal cash flows. But I want us to try. Let me check. Let me take you back, and that should. Sorry, I just take you back to this example. And I just wish to put. Okay, I will stop sharing just to incorporate something there, and then. Now stop share. Sorry, I hope you are able to see my slide. Right?
Yes.
Yes. Okay, so I want you to work on this, and I suppose for some reasons this might be the last exercise for today. Yeah, so you recall this example or exercise which you did, and you were able to compute the expected value. For example, for year one, what was the expected value?
$3,800.
Yeah, 3,800. So that was the expected value here. And what was the expected value for year two?
7,225.
Okay, for year three?
6,500.
6,500.
Okay, so those were expected values. Now, those are the ones we consider, or we call them as mean. So those are mean cash flows. Now, with the standard deviation, please ignore the last part. I mean, this part here. Could delete, and it doesn't work anyway. So, in and I don't know why I put it project Y again. And this was not the intention. I want you to use this just for that exercise. No, I mean, yeah. So using that example, you have the cash flows. So you have the cash flows, and then you have the mean cash flow. So the mean cash flow for year one is going to be how much?
3,800.
Yes. And what is the cash flows for year one? I think you have, sorry. Yeah, you have the cash flows for year one. You have 1,500, 4,000, and then 5,000. So these are the cash flows. So you have 1,500, 4,000, and 5,000 in this table here. I don't know if I should put this for you. So this is 1,000, and this is 4,000, and this is 5,000. So these are the cash flows, and what is? Just a minute. So okay, so what is the mean cash flow for year one?
3,800.
Yes. So what we are doing here, we will compute, I mean, the standard deviation for each year, and then the aggregate standard deviation. That is what we will skip for today. I mean, we'll complete that next in the next session, because if I understand, there are some few students who were not able to join, and I would appreciate to discuss that in the next session. So for today, what I want you to work now, and that should take us around 15 minutes or so. So we have to compute the standard deviation for the project or the Excel that we have. So the mean cash flow, I mean, you have mentioned, and this is going to be for, maybe to be specific, let's compute standard deviation for year one. So these cash flows are for year one. So you compute the standard deviation for year one, and then you do that for year two, you do that for year three, because with our project, I mean, we have year one, year two, year three. So we will do that for the 3 years. And what I'm saying, the aggregate standard deviation is what we will compute in the next session. Is that clear? Are you able to do that, or something is unclear? And if it's unclear, please let me know. Students?
Yes, that's clear.
Yeah.
Okay. So what is going to be here, if I ask you? What is going to be here?
3,800.
What is going to be here?
3,800.
What is going to be here?
3,800.
Okay, so you know what this means. And what is going to be here?
Zero 0.20.
And what is going to be here?
0.30.
0 point?
30.
Okay, and what is going to be here?
0.50.
Are you sure? I don't think, because recall, this is the table. I mean, we are referring to this. So I think this is where you have 0.5. Yeah.
Yeah, at the last one. 0.5 at the last one.
I don't think. The last one? Even tuna refer hapa au mimi sielewi. Sorry.
The second one ndo ina 0.5.
Yeah, the second one I think is 0.5. Ni sawa?
Yeah.
Yes. Okay, so I mean now you know what to do. So we do that for year 1, we do that for year 2, and we do it for year 3. And then you once you have computed, I mean the last item of probability times the square of the deviation, then you add them, and that is what we call a variance. So I mean simply compute the aggregate value, the variance. I mean just take the sum for year 1, for year 2, and year 3. So please, I give you a maximum of, I mean, let's say 10 minutes, and if we need more time, not more than 15 minutes. So all the best. And I will intervene, I think, somewhere around 8:42. That is when I'm going to intervene. Yes, are you done?
Yes.
Okay. So you have done it for year 1, year 2, and year 3. Hello?
Year 1 and 2 so far.
Okay, you have to do all the 3 years. The reference is here. So do it for year 1, year 2, and year 3. I mean, you can compute the standard deviation of the project after computing the standard deviation of each year first. So I give you 2 more minutes. Okay, so I suppose you are done now. Are you done, please?
Yes.
Okay, so what is the variance for year 1? I mean, just the sum. If you add this, what is the total?
1,510,000.
500 and?
1,510,000.
Okay. For year 2?
7,586,000.
Mm.
875.
For year 3?
9,750,000.
Okay. Do all, I mean, is there anyone getting different answers? I mean, different from this? Members, can I
No.
hear?
No,
So
no.
so you all get this?
Yes.
They're all the same.
Sorry, I'm not hearing from someone. So you all got the same answer?
Yes, sir.
Okay, then that's good. So I mean, if that is the case, then that is how we compute standard deviation. Sorry, yes, at least of a particular respective year.
No.
Sorry, someone said no. I heard someone saying no. Is it something else? Okay, Kama Siski. So I mean, this what I was saying. This is how you compute the standard deviation for the respective year, and then we're just remaining with. I mean, the way of computing the standard deviation for the project as a whole, and that is what we will address in the next session. Plus, I mean, measuring standard deviation using coefficient of variation and a bit of discussion on the dependent cash flow. Because this was more about independent cash flow. Yeah. So I propose we stop here for today. I mean, we have seminars tomorrow. If there is any, I mean, any student who is not who has not registered in the seminar, a respective seminar, please address that today through the Sierra, and then we will see how to sort it out. But we meet tomorrow for seminars. So have a good day.
Likewise.
Asante. Naona watu wanapika huko, msije mkaunguza.